All right, this is going to be part 2 of page C. We've got, like we just did solving some linear equations. Now we're going to solve some quadratic equations. There's a few ways to do that: by factoring, extracting a square root, or using the quadratic formula. So I'm going to go ahead and do these problems the way that I would factor them. You may have learned another way. Hopefully what I'm doing here rings a bell and gets you started on the right path. So it's important when we are solving by factoring, it's important that we have what our equation in what's called standard form. So ax squared plus bx plus c equals 0. Essentially it needs to say equals 0, have an x squared term, an x term, and a constant term. As long as it's in that form, you're ready to go ahead and start factoring. Now this one here is a trinomial. There's 3 terms. So I know that's going to factor into 2 binomial factors. So something like x plus 4 times x minus 7. I don't know what the exact answer is for this one, but we're about to find out. All right, I like to set up what is called an X or a diamond problem. And I'm going to be figuring out 2 numbers that multiply to be 28 and add to be negative 11. Those are going to be kind of keys for us to factor. So in this case, 2 numbers that multiply to 28, a couple options: 1 times 28, 2 times 14, 4 times 11. But none of those add up to a negative. So there is another way for us to multiply and get 28. Could be 2 negative numbers. So I think that's what it's going to be this time. It's actually going to be negative 4 and negative 7. So when I multiply those together, I get 28. So multiply. And when I add, I get that. Okay. So there's a few ways to go ahead and do this. This is a little bit of an easier problem to factor because this coefficient, the number in front of the x squared term, is a 1. So there's not a lot of extra steps here, but I'm going to go through the full process. Okay. What this allows us to do is to split up this middle term, this negative 11x. We can split it up as negative 4x and negative 7x. And that is going to allow us to fill out what's going to be called a generic rectangle or a factoring box. Or if you're one of Mr. Bechtel's students, a Bechtel box. Now we have 4 terms. We have x squared, negative 4x, negative 7x, and 28. I got the negative 4 and the negative 7 from this diamond problem here. And I'm going to fill out my box. X squared, negative 4x, negative 7x, 28. Okay. And now we're going to figure out the numbers that go on the outside here that would multiply to give us what's on the inside. So like this number here and this here need to multiply to give us that. Or the number here and the number here need to multiply and give us 28. Again, since this is a little bit of an easier one, I know really the only way I'm going to get just x squared is an x and an x. That kind of gives us a little bit of a quick way to start. If there's a number in front of x squared, it's a little trickier, a little more complicated. All right, so now I can think about x times what is going to give us negative 7x. Well, that needs to be a negative 7. Negative 7 times x, and that gives us that. Then I can think about the same thing. I have a couple options. I can think of this. What number times x is going to give us negative 4x? Or what number times negative 7 is going to give us negative 28? Well, same thing. It's going to give us negative 4. These are our 2 factors for this problem that we have here. Our first factor, though the order isn't really important here, x minus 7, that's along the side. And our second factor, x minus 4, equals 0. This is the factored form of this original trinomial. If you went ahead and multiplied that out, use your distributive property or FOIL or whatever method you have for multiplying things out like this, you'd end up with that original thing. They are equivalent. Now, final step here, when you're solving, you're actually trying to find solutions, values of x that make this a true equation. we have to use what's called the zero product property. Whenever you have two things that multiplied to be equal to 0, that can only be true if one or both of those things is 0. So you have to figure out what value of x would make this factor 0, and what value of x would make that second factor 0, and those are going to be our two solutions. Well, turns out they're pretty easy. 7 minus 7 is 0, so one of our solutions is going to be 7. And 4 minus 4, so that's going to be 0, so the other solution would be 4. If you're not sure, you can actually just set up some equations. You take your factor, x minus 7 equals 0, and you solve it, but that's just going to give us this solution. When you take your second factor, set that up, set it up equal to 0, and well, you just get your second solution. So these quadratic equations tend to have two solutions. They can have two solutions, or they could have one solution twice, a double solution, or they can actually have no solutions at all. And those are all kind of options. All right, that's a pretty long process, and you can see I don't have a lot of space left on here, but I am going to do a couple more of these because it's an important topic. All right, so second problem, you'll notice it is in standard form. It's set up that way. If it's not, you need to make that happen. So like on number 7 here, since this side is not 0, I need to, well, it's minus 20, so I need to add 20 to both sides and kind of move that over so that I have 0 on one side. But since this one's already set up, and it is one of the harder ones, I guess we'll say, since there's a number in front of x squared, I'll go ahead and do that one. All right, now the process for setting up the first step, the diamond problem or the x problem, is just slightly different here. Because I have a coefficient, a number in front of x squared, I'm going to have to use that while I'm setting things up. So I multiply the coefficient here times that. It's going to give us negative 24. And the middle number still just goes on the bottom. So I'm looking in this case for two numbers that multiply to negative 24 and 5. Again, that's a little different because of this coefficient, because that number there. It adds a little bit of spice to the problems. All right, so we're looking for two numbers that multiply to negative 24 and add to 5. I always just go for the numbers that multiply. It's a shorter list. What numbers multiply to give me this? I need one positive and one negative. That's the way we can get a negative number. And there's only just a couple options here. So our answer is going to be negative 3 and positive 8. Those are the two numbers that will multiply and give me this, but add to positive 5. Again, remember, the point of this is splitting that middle term. So it's going to be negative 3x and 8x. That gives us our 4 values to fill into the factoring box or the generic rectangle. You might know a shorter way for doing number 5. Feel free totally to do that. Whenever you don't have a coefficient, you can actually go a lot shorter than I did. You don't necessarily need to do this box, but on these ones, it might be necessary. All right, filling that out, we have 2x squared. And then these two terms, so negative 3x and 8x and minus 12, negative 12. All right. What is going to go on the outside here? Now, again, I don't have sort of the free start that I had last time. I can't just know that it's x and x. One of these is actually probably going to be 2x and x, or maybe even something else. I think that's going to be the case in this one. Another way to fill out these factoring problems like this is looking for the greatest common factor in each row or in each column to kind of get yourself started. So in this case, I'm going to go ahead and look in this column. I have 2x squared and 8x. Both of those have an x. They have an x in common. Not x squared, because this one doesn't have x squared, but they do have x in common. And then our greatest common factor between 2 and 8 is 2. 2 is a factor of both of those numbers. They're both divisible by 2. So they have 2x in common. That's going to give us a nice starting point. So now 2x times what would give us 2x squared? Well, we need another x to get that x squared. And now we're off to the races. Now we can just keep going, right? 2x times what is going to give us 8x? Well, we need a 4. 2 times 4 will give us 8. And then we kind of keep going here. X times, well, -3. So it's -3x. And then you just want to check and make sure it works throughout. -3 times 4, yeah. Those all work. All right, so our factored form, x plus 4, because that 4 was positive, 2x minus 3, because that 3 was a negative, equals 0. That's the factored form of that original trinomial up there. Now, one of these is a pretty easy one. You know, you could probably figure that one out already. What would make that factor equal to 0? Well, a -4 plus 4, that would make it 0. So one of my answers is going to be -4. But if you're not sure, go ahead and set up the equation. X plus 4 equals 0. Solve it. You'll go ahead and get that solution. Second one, not quite as obvious. So I'm actually going to set that up and solve it. So what would make this 0? So I take that and set it up. Set it up as an equation. Add 3 to both sides. I get 2x equals 3. And then divide by 2. Get x is equal to 3 over 2. A little bit harder. Answer was a fraction. Wasn't quite as obvious to see that solution. Anyway, but these are our two solutions. If we plug either of them back into the original problem, we can see that it would work. So I'll go ahead and do that with one of them just to make sure. So I'm plugging in -4 here for this. Okay, so it's going to be 2 times -4 squared plus 5 times -4 minus 12. And that should equal 0. Hard to see that. It does. And I could go ahead and put in 3 over 2 as well, just to double check it. I could put that as a decimal too, but yep, works as well. So